All right, good morning, everybody. I'm Rob Wertheimer. Welcome to the Share Series Monday Management Update. I have the pleasure of speaking to Heliogen CEO Christie Obiaya today. And as a reminder, anytime during this, please use the question button at the top of the video player and you can submit a question and we'll get it to Christie at the end. So the format is we're going to start out with a couple of thoughts from Christie and then we'll do some Q&A and then you can chime in at any time with the questions. And with that, I'll turn it over to Christie.
Great. Thanks, Rob, and pleasure to be with you all this morning. As Rob said, my name is Christie Obiaya. I'm the CEO of Heliogen, and I'm excited to be with you all today. A little background on me. I joined Heliogen about 2.5 years ago, initially as the CFO, and recently stepped into the CEO role about 6 months ago. And in the last couple of years, Heliogen has been very busy expanding on our products. And I want to tell you about what we've been doing really over the last several months, over the last 6 months, the progress that we've made, where our focus is, and just give you a bit of a background on the company before we get into Q&A with Rob and then open it up for the open forum. So first, background on me. I came to Heliogen with most recently about 11 years of experience with the global engineering and construction company Bechtel, where I was most recently the principal vice president and head of strategy and CFO for Bechtel Energy, the largest global business unit for Bechtel. And at that time, Bechtel itself has been doing a lot in the energy space. And prior to coming to Bechtel, I spent time in energy and infrastructure in other organizations, and I started my career as a chemical engineer. And so this has been sort of an overall path of straddling the space of energy, infrastructure, and finance over the course of my career. And so coming to Heliogen, the thing that brought me to Heliogen was really the differentiated technology, the mission that we're on, which I'll tell you about in a moment. As well as the incredible team that we've built here at the company. And so I want to jump into the slide deck now, and I have a couple of slides that will give you an overview of what we're doing here at Heliogen. And on that first slide, it's basically our company on a page. The challenge that Heliogen is looking to solve, if we could go to the next slide, please. The challenge that Heliogen is focused on fundamentally is on solving the industrial decarbonization challenge that's in front of us. In general, you've heard about renewable energy, I'm sure, solar, PV, wind. These are all intermittent sources of energy, whether they be for power or heat or what have you, however they're being used. And right now, there is no solution for industrial decarbonization that doesn't have some sort of either intermittency or extremely high cost of storage. When the sun's not shining and the wind's not blowing. And so what Heliogen's focused on is decarbonizing and enabling a sustainable low carbon future through a combination of solar thermal energy technology. And this is something that Heliogen really does uniquely, powered by artificial intelligence. And I'll get into in a little bit how exactly we do that. But Heliogen is able to offer to the market, and when I say the market, I mean industrial consumers of energy, which represent over 25% of the total energy consumed on the planet. We're able to offer solar thermal energy, which can be converted to clean heat or steam, clean power, and clean hydrogen when we bring in an electrolyzer. What we're focused on is a series of different markets. I would say probably the largest market when we look at our pipeline is mining and metals, but we often see a lot of interest, a lot of inbound interest that's growing in our pipeline from other industrial users ranging from oil, gas, and chemicals to data centers, to utilities, to heavy equipment. So these are all the areas that we're building out in terms of our sales pipeline and our portfolio. And really, we locked in our product shortly after I stepped into the CEO role. And in locking in our product, that's when we were able to offer a consistent face and offering to the market, which now is our first available commercial product is a clean steam unit. And then we're also building out our portfolio for our power offering, which is something that we're going to be able to do when we add a turbine to existing solar thermal energy storage. And that will be used to create green power that will be available nearly around the clock. And so that really will serve industrial consumers that have a need for power. In terms of how our business model works, and I'm just going, touching on each of these different segments, and we can come back to these in more detail during the Q&A. In terms of how our business model works, we offer a couple of different options. I mean, at this point, we're really flexible with what our customers may be looking for. For example, some customers are very interested in owning the plant, having the plant located on their premises. And this is especially the case for heat customers, where we see there's a huge benefit to being in close proximity to the end use of heat, because of the fact that heat does not travel easily compared to other forms of energy, not like electricity, which can be transmitted over a distance of 100 miles. Whereas with our heat offering, we're able to be sited right behind the customer's meter. And because of the fact that we have a modular offering that can be scaled down or up to suit a customer's needs, we're able to locate right there on site on adjacent land that the customer has. And our energy efficiency is actually higher than PV when you look at the inclusion of storage in our offering. And then finally, looking at our vertical integration and our modularity, we actually produce some of our own tech vertically integrated, and that's both on the software and on the hardware side. And that helps us deliver a more competitive LCOE than would be possible if you're just looking at intermittent forms of energy with battery storage. And then just some background on the company. We're at about 180 people strong right now. We have a couple of locations across California, including a demonstration scale facility, which I'll tell you more about. We have our production facility in Long Beach, California, where we make the mirrors as part of our offering. And then we have an office in Houston, Texas. And we've got 2 commercial projects that have fully executed contracts, and we're in different stages of engineering design phase 4 right now. So that's a bit of background on the company. I want to dive in a little bit to how the technology works. So I think I've covered the next slide. If we could skip to the slide with the next slide, please. If we could skip to the next slide, that's perfect. Okay, so a little bit of background of how our technology actually works. We have a patented combination of hardware and software that we are able to use to dynamically control thousands of mirrors all at the same time with real-time feedback. And the way that this happens is, if you look at the graphic, you'll see there's a field of mirrors, and that field of mirrors is what reflects the sun's light back at the top of the tower. And when I mentioned solar thermal, again, different from solar PV, which takes the sun's light and ultimately uses that to convert to electrochemical energy. Instead of electrical energy is thermal. And so what the mirrors, that field of mirrors that you see in front of the tower, what that's doing is it's reflecting the sun's light back to the top of the tower. If you were to go out and put your hand on one of the mirrors in our field, it would feel cool to the touch. It's not hot, because all it's doing is reflecting the sun at the top of the tower. And at the top of the tower, then you see the numbers 1, 2, 3, and 4. Those are the numbers which represent 4 camera positions. We have cameras at the top of the tower, and each of those cameras is looking at the field of mirrors all at once, and can see and control every individual mirror in real time. And so what that allows us to do is, if any particular mirror is off center from those 4 cameras, it will end up showing up more brightly in one camera than in the others. And so we will know that mirror is off focus and can automatically adjust it. This technology was only made possible relatively recently with the invention of the NVIDIA GPU processor, and because it does take a lot of processing capacity to be able to do that, and to be able to include the machine learning with this solution. But what that does is it enables hardware innovations that wouldn't otherwise be possible without the software. And so, for example, prior iterations of this kind of technology, because these, what we call the power towers, the field of mirrors in the tower has existed before. It's been commercially proven. There are many operating plants all over the world. But what we're doing differently is this dynamic monitoring and tracking and adjusting of the mirrors. And so by being able to do that, we don't have to keep the mirrors as stiff as we would have had to in prior incarnations of this tech. And so now we can actually start taking out steel and stiffening aspects that were used previously to hold the mirrors really stiffly, so that as the wind blows, as the foundations settle, you wouldn't have to be out there manually recalibrating and going through these time-consuming calibration steps. So we get not only improved efficiency out of the field, but you also save time and calibration with our solution. And then, of course, from an installation perspective, that becomes a lot easier when you're dealing with a simplified approach to the hardware with the mirrors. We do, as I mentioned, have a manufacturing facility, and that is where we assemble the mirrors in Long Beach, California. We source the mirrors. There's a lot of different, but all kind of readily available materials. We don't use any substantial rare earth materials like you would see with certain other kinds of renewable energy, and so that's also one of the benefits for us. And then when we look at the kind of the core IP, we were actually able to prove the functionality of the IP as part of our demonstration scale facility, which is still up and running in Lancaster, California. And so we've been in California for a couple of years with this plant using that as an R&D test facility for our next generation technologies. We've started using that facility even more differently as we scale up and prepare for our first commercial scale projects. And so if you go to the final slide here, right now, we have two fully executed contracts, and I'll use this slide to explain where we are with each of these. The first contract is with Woodside Energy, who's the largest oil and gas producer in Australia. And that is for a project that will be a 5 megawatt power facility in California, where we take our heliostats, the tower, and we are actually demonstrating a next generation storage. And so I talked to you about thermal energy storage being a key aspect of our offering. Well, in that particular contract, we're actually demonstrating the next generation storage using a solid bauxite particle. And that's one of the things that makes that particular project with Woodside Energy really innovative. We are also on that project applying a Department of Energy award that we won in 2021. And so that project in general is going to be the first demonstration of its kind to apply that novel next generation storage. And the benefit of that storage is to get to even higher temperatures, which is going to be the kind of the holy grail for our technology and for the industry, I believe, in looking at what you can do with high temperature. So with that storage, we're able to power a generator, and we have a relationship with Hanwha, the Korean company, on a supercritical CO2 turbine generator for that project with Woodside Energy, which we call the Capella project. And then the second contract that we've signed is actually for producing green hydrogen. And so that's where we use the heliostats, the receiver, the storage to produce green steam. That's with our first to the market available green steam unit. And then we combine that green steam unit with power that we're actually getting from the grid. So it'll be green energy from the grid. And we can use those two input sources as the energy that powers a solid oxide electrolyzer. And we can get more into the details if anybody's interested in what's unique about that. Short answer is solid oxide allows us to use both steam and power as inputs. And with steam being cheaper to produce than power, it gives us an efficiency benefit to use a solid oxide electrolyzer. And so with that, we'll be able to deliver on the contract, offtake contract that we've signed with the city of Lancaster, California for green hydrogen at $10 a kilogram. And we look forward to delivering for them. And that'll likely be our first project up and running. So with that, hopefully that gives you a bit of background on the company, and want to hand it back over to Rob for Q&A.
Perfect. Thanks, Christie. So it's fascinating. And you touched on a couple of topics that make Heliogen different. One of them is just advanced technology and AI that allows you to sort of gather in the sunlight and more efficiently. Another is that you can solve hard to sort of solve decarbonization issues. And you mentioned process heat. So can you kind of compare and contrast what Heliogen can do either at all or more efficiently than what solar PV can do? And what are those what's an example of a hard to solve issue?
Yes, great question, Rob. So one example, there are actually several examples of what we call hard to abate industries. These include cement processing, steel manufacturing, anything that uses very high temperature heat to create energy, anything that uses very high temperature heat to effect any kind of process change, a process transformation, a chemical change. Those are all areas that would be considered hard to abate because there is no current green solution that can do this. In general, most of these types of processes that use high temperature heat all burn fossil fuels somehow. And so any technology that could replace fossil fuels is really in its kind of early emerging stages. And what Heliogen's been able to do is, at our demonstration facility, we've proven that we can reach temperatures in excess of 1,000 degrees Celsius. And that's been validated by a third party at our demonstration scale facility in California. And so we're actually working with a potentially long-term customer called NYSE Power to develop the conceptual designs for what it would look like to create a commercial offering for things like calcination. And calcination basically is one of the types of processes that uses high temperature heat in cement manufacturing, for example, or lithium extraction. Those are areas where the calcination process is used. And it basically means getting to high temperatures, 800 degrees plus Celsius. So we're working on what that commercial product looks like as part of our roadmap, partnered with NYSE Power as our customer for those kind of early design services. And so we have conversations with customers, especially in mining and steel manufacturing, that have a need right now for lower temperature steam or power, which are earlier available products that we can offer. And so we talk about, okay, you can get on this train with Heliogen at the lower temperature steam and at the power offering unit, and stay on the train all the way through high temperature heat as we develop those offerings. And that holds a lot of appeal for people.
Excellent. So for example, you have process heat that gets involved in a mine or any other industrial process, really.
Yes,
Right now,
yes.
you'd have to use a ton of solar panels and use resistance heating or something, whereas you guys collect all the sunlight and just focus it, right? So
Exactly.
do your customers see those issues as hard to solve? Are they willing to tackle them, or are they trying to go the easy solution of just plopping in, solar PV during the day? I mean, what is their thought process around their conversations with you?
Yeah, so first of all, I think some of this has been a process of education, especially in the US, where the concept of solar thermal energy tends to be less well known, less well understood. In other parts of the world, though, this technology, it has many operating plants all over the world. There are plants that have the concept of the field of mirrors and the towers that exists in countries like Chile, Israel, China. They're building many plants right now. There's all kinds of countries in the Middle East where they've had these plants up and running, Spain as well. And many of these plants were built and installed in the 2000s and early 2010s. And we've been able to really leapfrog kind of the older versions of that technology with what we're offering at Heliogen. And so the nature of the conversations that we'll often have with customers are initially kind of more on the education front of, look, here's an opportunity for you to not have to use high cost batteries to green your portfolio. And so that's one source of appeal. Another source of appeal is the flexibility of being able to produce both heat and power. Whereas if you're looking at solar PV or wind, those have conversion inefficiencies when trying to get from kind of the fundamental source of energy, which in that case is not often heat, to what we're doing, which is starting with heat, and then we're able to use it in its purest form and not have energy losses.
You touched earlier, Christie, on not a lot of rare earths in your product. There's a lot of, steel and glass. I mean, it's a pretty simple thing. It's a mirror and high technology, let's say, software.
Right, exactly.
Can you talk a little bit about your manufacturing strategy when you get to sort of volume production? Are you guys ready to do it? How do you approach the ability to sort of ramp?
Yeah, our manufacturing facility right now has the capacity to produce the mirrors or the heliostats for all the projects that we have that are in our immediate term. And then as we look at, for some customers, I'll give you an example. We're talking about what we'll call a phase 1 and then a phase 2, where the phase 1 might be like a 10 megawatt facility and phase 2 is the 50 to 100 megawatt facility. And those are the kinds of conversations that we're having with customers right now. And so for the initial offerings, we feel well positioned to be able to meet the needs with what the facility that we have in Long Beach, California. And then when needed, we'll be prepared to ramp up by adding additional manufacturing lines, adding additional CapEx to that facility, or depending on location, building out other facilities, which this is really designed to be able to help us do. So we'll be able to scale up very well once we have the right backlog contracts. And so part of this is just about managing CapEx spend and just being very thoughtful about how and when we do that relative to the contracts that we have signed.
And you mentioned one of the things that differentiates you versus older solar thermal technologies is the NVIDIA, the ability to target very precisely the technology in it. You also have, I think, a high technology kind of manufacturing team. And so I'm a little bit curious if you can expand on the iterations you've done, the work you've done to sort of take away just the nature of technology that you have means you don't have to have these massive installations to keep a mirror stable in the desert for 20 years, which is hard, right? But you also have a very iterative approach. And I wonder if you can sort of talk about that for a moment.
Yeah, on the hardware front, we have had multiple generations of our heliostat. That's the heliostat, again, is the mirror that tracks the sun. And starting from many years ago, there have been several different iterations that we've actually tested in our demonstration scale facility. And so more recently, we've said, okay, let's just focus on accelerating our path to get our first commercial scale project installed. And so as we've been, as we've been looking at what commercialization looks like, we've said, okay, let's pause on the extensive focus on R&D and on continuing to iterate with next generations of technology. And really, let's lock in what is our first product facing the market, and let's go ahead and deploy. And of course, we're always going to come up with additional iterations and improvements. And, you've been to our facility and have had a chance to see it live. We are focused on let's go and deploy what we have right now. And then in parallel, we're having some very kind of focused, targeted R&D efforts that we do continue, where we do still use our Lancaster facility. We'll produce the mirrors or the heliostats in Long Beach and actually trial them in Lancaster. And some other areas where we've done that are for our automated cleaning machine. We have an automated cleaning vehicle that has been running since January of this year and successfully cleaning mirrors at our Lancaster facility. And that's exactly the kind of thing that we'll be deploying on customer sites. And so when we talk to customers about our capabilities, our team, our automation, many of the folks on our team came from, very kind of automation intensive, as well as just very industries that had to break the mold and be creative. So some of our team worked directly with Elon Musk at SpaceX. And so that team is very well positioned to be able to help us with whatever kind of future opportunities that we have to increase things like automation of installation in the field and those kinds of things.
Perfect. We've got one from the audience, which is an interesting question. So to sort of touch on what you guys do, is the helium technology price competitive in the solar panel market? You mentioned two of the potential clients would be mining and metal. Rio Tinto recently announced the build of a large solar plant in Canada's north, which I didn't know. Is that out of scope for Heliogen? And maybe, are you commercially competitive in that way? And maybe you could just sort of use that as a springboard to talk about where you're different.
Yeah, absolutely. So our commercial competitiveness, when we look at the areas of the world that have really strong solar resource, that's always one of the key screening criteria. And there's always going to be some overlap for us between where the solar resource is good for solar thermal and where it's good for solar PV. There's some minor differences there, but in general, in sunny parts of the world, our technology makes a lot of sense. Now, where we compete best and can win against solar PV is where customers need high, either what we'll call long duration energy storage. So essentially, if you're operating where you need a high capacity factor, or where you're operating many hours of the day and not interested in opportunities where you're either up or down or blending with a lot of usage of power from the grid, those are great opportunities for us to come into play. And we're not, we actually are open to including PV, partnering with PV, that kind of thing. This is not a we're the only thing that works kind of thing. But the benefit for our tech is that solar PV has to work with batteries in order to have a storage solution today, whereas we don't. And so for us, our real differentiator is being able to use the cheap version of storage, which is solar thermal energy storage. And we can do that with proven solutions like molten salt, which is used in projects all over the world and these kinds of projects, as well as the more novel types of storage like solid state or particle storage, which has not been used as much commercially, but part of the reason is there has not been available solutions that can get to the higher temperature heat. And so that's the kind of thing that we're working on with our partner, Woodside Energy, who's been a really strong partner for us on this and sees the opportunity of solar thermal energy storage. And so that's where we could really, coming back to the price competitiveness, be price competitive with alternatives out there.
Perfect. So not on pure electricity, but on delivering, high quality heat or steam or 24-hour power kind of thing.
Exactly. Like if you were to say, who can produce 2 hours worth of the lowest cost energy during the afternoon, that's going to be solar PV all day. But a lot of customers, when we talk to them, that's not what they're looking for. They're looking for the 4 hours plus storage. And that's where it's like, okay, well, there's actually not even that much third-party research that shows the 4+ hour duration storage side by side with different technologies. And so that's when I talked about education earlier, those are the kinds of things that we're working with, consulting firms and what have you, to try to paint a more apples to apples picture of where our technology therefore competes, because it's really all about that long duration energy storage.
Perfect. We have another one from the audience. If you could just address the dates of completion or initiation for the projects you mentioned, for the contracted deals you mentioned.
Yeah, so for the so our fastest product or project that we can build is something that uses our first to market product, which is our steam unit. And therefore our steam unit, which we're first applying to projects like the Proxima project. I don't think I told you that the name of that one, but that's the one where we have the green hydrogen offtake. That steam unit will be up and running in early 2025 after completion in 2024. So that's our expected timeline for that project. We're already underway with engineering, and the two time critical areas there are the permitting process in that local area in California, as well as the long lead equipment. But the actual construction and installation and the mirrors and all of that, those are not anywhere close to being on the critical path. So it's really more the kind of basic off-the-shelf long lead equipment items that any other energy facility would have in front of them. Along with just the kind of normal permitting process. So that's the Proxima project for green hydrogen. And then for the Capella project, which is the project that we have with Woodside Energy, you may recall that I mentioned about 15 minutes ago that our contract with Woodside also includes the application of a Department of Energy award. And because we have a Department of Energy award, there's a set of additional risk reduction initiatives and testing that comes with that award, about 12 months of testing. And so that's not a plant that we expect to be operating with all of the full data within the next year or two, because that in general, we've always expected that project to take several years to deploy. And so we're looking at mechanical completion in several years based on the fact that we'll be doing that additional risk reduction testing and just the technical aspects of the Department of Energy award. So we expect that we'll have several other projects up and running before that project is complete, which makes sense also because of the fact that that's a newer particle technology that we're going to be demonstrating.
Great. And then we've just got a minute or so left. I think you've got a pipeline that's grown, pipeline potential customers that's grown by something like 700 megawatts in the last 3-4 months. Can you talk about what's causing that momentum, what's causing the shift? And you've got about 90 seconds to answer.
Yes, we're really excited about our customer pipeline growth. I think really the simplest way to explain that is really just to focus on sales. The focus that we've brought is the narrowing of what we're actually offering to the market, and a alignment between our sales team and the product work that our engineers have done to offer that clear, consistent, offering to customers, and to focus on customers that have the needs that I described earlier. It's the fit with the strong solar resource, the portfolio that they need in terms of their energy consumption, and those kinds of things. Those are all what's contributed to us being able to really proliferate the pipeline. And so looking forward to that materializing into signed contracts in the coming months. Perfect.
I think we're just about out of time. So thank you so much, Christie, for joining us. Fascinating stuff. We appreciate it. And next up, I think, is Medexus Pharma. Thank you.
Thank you, Rob. Thanks for having me.